Hello, respected critics and jurors. Hope all of you are having a great day. The name of our project is Designing for Curiosity, and on that, my design focus was to initiate a sense of wonder and curiosity with the help of cooperation amongst preschool children who were aged from 3 to 7, while being fully autonomous from the adults, with carefully leaving out seemingly undesigned parts that are to be designed by the children themselves for incidental science learning. The first stage to initiate the design was to choose a process, and as a research-based design, in this particular case, we had to establish a scale to measure if our design was going towards the right direction. Validity and reliability were key concerns. The goal of the design was to assist early childhood science learning via the design environment. Therefore, the quality of the environment had to be measured. To make sure that the measurement was reliable and valid, a scale of measuring the surrounding of the children had to be derived. In order to do that, we went through two different scales that are established to measure different aspects of children's surrounding alongside quality of their different activities. They are Early Childhood Environment Ratings Scale Revised ECERSR and Preschool Outdoor Environment Measurement Scales or POEMs. After doing so, we picked the questions that are related to environmental rating and used Qualtrics to merge different question types to formulate a rating system with the usage of simple mean and percentage to get a generalized evaluation method for the quality of natural surrounding in terms of early childhood science learning. The given site was the CDRC or Children Development Research Center located inside Texas Tech University. To initiate the design, 7 researchers ran the environment rating scale that was initially derived and rated the existing environmental condition of the site. The questionnaire was divided into 3 domains: physical environment, features for science learning, and interactions domain, both with nature and the caregiver. Researchers were able to rate only physical environment and features due to absence of children in the site for COVID-19 situation. Almost all the results from different researchers lie in a very close range in terms of rating. It gives a sense of validity, as even though the scale is meant to measure qualitative and subjective matters, the researchers were not subjected to interpersonal bias. The scale did not only show the quality of the environment, it also derived several issues regarding the environment's lacking of science learning elements, which in turn translated into program. Some of these lackings are lack of math or number learning elements, science talk scopes, observations and events for science learning, interaction with adults, space for mess and noise, shade for everyone, proper zoning, space for art and drama, and water play. After deriving the basic design requirements, the zoning was done keeping in mind the existing trees and major activity zones, which were the tall tree with the seating arrangement underneath it at the center of the site, the sand play zone, and the sundial. Apart from these, tree plant zones, educational zones, play zones and challenge zones were introduced. But a major target of the design was to make it holistic by connecting separate zones with a looping road network. In order to do that, the initial iteration became something like this after optimization of the road network. After the initial iteration, an attempt was made to clusterize the zones that contained similar activities, creating a behavior gradient in different times of a single day. On the process, the hierarchy of the path network, primary, secondary, and tertiary, became prominent. The third and final iteration began after visualizing the journey through sketches of different activity zones. This iteration came up with details of the path materials, undulation of the surfaces and pathways, positioning the loose parts for interactive play, shade for everyone, and most importantly, with proper width for the primary, secondary, and tertiary paths, which are 5 to 12 feet, 3 to 4 feet, and 2 to 3 feet respectively. The planting design of the overall master plan had to be done in a very sophisticated manner due to the extreme temperatures, low rainfall, and height from the sea level of the high plains region that Lubbock is a part of. A major concern in this matter was to use as little water as possible for the planted trees and make it drought tolerant. The key technique that was used to provide a cool, damp place for the roots to grow in hot weather was the usage of large stepping stones in the secondary and tertiary pathways. They provided with walkways while also creating flower beds, provided protection for the roots in winter, cut down on weeding and prevent erosion. Each of the activity zones are slightly contoured, creating a shallow swell that collects water draining from the concrete and stone pathways. This created the scope of growing trees and shrubs on its bank with a minimum of supplemental water. Watering was done through deep overnight soaking with drip irrigation systems or a soaker hose to prevent evaporation in the dry condition of Lubbock. The concept behind the planting design was to provide with a sense of gradual progression, from the entry through a forest-like path to a sudden large opening of the learning zone, from the human-sized perennial bushes to the seasonal flower beds surrounding the pathways. Each plant typology was placed keeping in mind a graduation of the journey. This was done to keep the wonder in the mind of a child running wild, and make the journey from his or her perspective metaphorically endless, through adventurous pathways, availability of loose parts like acorn, mulch, pebbles, or twigs, and to celebrate the seasonal changes that brings a dynamism of the nature into the cognitive domain of children, enhancing their curiosity towards natural phenomena. Large shade trees such as bar oak and Chinese pistache are occasionally used to provide sufficient shadows. Thus, a balance between deciduous and evergreen trees are kept, where alongside native trees such as cedar, elm, Texan redbud, etc., non-native trees that likes the local temperature but only needs a bit of water to survive, such as alligator juniper, weeping juniper, Colorado blue spruce, Rocky Mountains, European black pine, Chinese pistache, and chinquapin oaks are also used. The ground cover mostly contains of buffalo grass, blue grama, and Indian grass. In the meadows, alongside the ground cover, annual yellow wildflowers such as Mexican hat, as well as chocolate daisy, white milkwort, lazy daisy, and dahoka daisy are used. A mix of all the seasons were kept in mind so that the extreme temperature difference between the seasons doesn't make the designed landscape totally barren. Therefore, for winter, trees like Moor oak and Colorado pinyon are strategically used to provide foliage. And for ground cover, charming creeping barberry with rosy flowers, New Mexico ponyfoot, and winter fat are used. For spring, frog fruit is used alongside other ground covers. For the shady places, blue widow's tears, lavender's spiderwort, wine cup, and for the sunny places, sleepy daisy and lazy daisy are used between the stones. For the late spring and summer bloom, bush morning glory, yellow plainsman, and in the fence, Apache plume are used. Under the shade, fern acacia is used. Also, mini groves using soapberry and prairie flameleaf sumac are also constructed. For fall, four-wing saltbush, perennial buckwheats, feather dahlia, as well as Harvard oak that produce unexpectedly large acorns are used. After considering everything, the design came to a virtual construct, and the journey starts with an entry under a wooden gateway that is thriving with crossvines. Upon the entrance, the children are welcomed with the vastness of Mother Nature through the forest zone, where the abundance of loose part creates the scope of collaborative play such as installation or natural construction fort. Also, fallen logs naturally encourages a child to balance walk, where others will follow. And while doing so, this play creates a natural risk-taking experience. These activities and experiences create the scope of incidental science learning, as the wilderness can contain infinite number of natural phenomena to trigger the curiosity in a children's mind. Also, adventurous pathways under tall trees create the scope for the children to take charge of their own experience and design their own journey. The occasional transformation of the primary pathway into cozy sitting and semi-hidden nature of the internal tertiary forest paths enhance the intensity of this experience. The semi-hidden nature and cave-like connections are followed throughout the whole master plan in different expressions. At some place, it is the main pathway that goes uphill, creating a cave to pass from one place to another. Somewhere it is in the form of a willow grove, and in some places it is just a large pipe-like structure that runs through the wall of a surrounding playscape to another. After passing through the forest zone, the children come to a grand clearing where the existing sundial is located. The linkage with nature and learning is directly visible in this equipment, and the surrounding is enhanced for growth of analytical thinking through the drawn maze in the ground. Further progression takes the children at the central outdoor learning zone under the existing tree. Seating arrangement is built radially around the tree, and directly under the tree is a platform which can be of multifunctional use, such as nature observation deck or a stage for a drama. Adjacent to the central OLE, the edible plant zone is situated. This will teach the children the difference between edible and non-edible plants, as well as introduce them with the diversity of flora of the region throughout different seasons. Beside the learning zone lies the play zones, which is divided into three parts: water, sand, and earth play. Water play is a very shallow remnant of plialex with arrowhead, knotweed, baby's breath aster, and smartweed as surrounding flora. Water play zone can turn into ice in winter, and in the warmer seasons, exploration of aquatic lives will trigger science learning. The sand play opens up scope for imagination and earth play curiosity. At the exit of these zones stands a set of faucets, which will teach the children responsibility via the act of cleaning self after getting dirty. At the northeast corner, the challenge zone is situated. It is also divided into three levels of challenges according to given difficulty. Easy challenge zone is a mildly steep contoured meadow where children can fall down and learn to get up. This zone consists of various wildflowers. Next challenge zone is a ladder-like structure which is deemed as intermediate challenge, and the last is difficult challenge, and it is a rope climbing composite structure. Internally, almost all of the master plan has no boundary lines except for some low height hook and rope connection to prevent children unknowingly stepping into the wildflowers. Upon the completion of the final iteration, the environment measurement scale was rerun. It showed a significant improvement. Also, the diversity and clarity of zoning provides with a scope of diversified behavior pattern throughout the whole site in accordance of different times of a single day. A speculative behavior mapping shows the change of density respectively in class times or outdoor learning, recess or play times, and non-guided exploration times. In conclusion, it can be said that most of the approaches that are taken in this design process are done in a manner so that children have to immerse in a cooperative activity to enjoy the fullest and get a shared sense of curiosity while doing so. After all, we all are trying to find out a way to a nostalgic future where nature learning will be the key learning process.